So let's get to business. The next thing we have here is to convert this following quadratic equation from the standard form they are to vertex form. That's the question. Convert the following quadratic equation from standard form to vertex form. Solution now. Convert, that's the question. How to convert quadratic equation from standard form to vertex form. So they now say convert the following equation from standard form to vertex form. The first one, number 1. Now, what is the standard form of every quadratic equation? We've said that. That the standard form of every quadratic equation is actually what? Ax squared plus bx plus c equals 0. And the vertex form, where a, b, c are constants, right? And the vertex form is a into bracket x minus h all squared plus k equals 0, where h comma k is the vertex. Is the vertex. All together, this is the form we want to convert it. We want to convert this quadratic equation, this one number 1, this one number 2, this one number 3, from this standard form. It's looking like this, right? We want to convert it to something of this image. Now, how do we do that? Let me show you real quick. Now, number one, we have x squared plus 6x plus 5 equals 0. Now, the first thing we do is you pair it. Let the constant be at one side. That will be what? X squared plus 6s, then positive 5 somewhere equals 0. I want to get that here now. Now the next thing you want to do is to make this a perfect, write it in perfect form, like a perfect quadratic equation. What do I mean by that? So that it's going to be x plus something all squared, or x minus something minus a number squared. And how do you do that? Just like completing the square, you take the half of this one, half of the coefficient of this. Let me use another ink here, right? Let me say you take the average of the coefficient of this, half of the coefficient of x, that's this, square it, add it to this. And then, watch what I want to do. I will say the next thing I will write is what? That will be x squared plus 6s plus 3 squared is 9. No. Plus, let me write it as the half of this is 3. Then I will write plus 3 squared minus 3 squared plus 5 equals 0. Somebody is saying, what's the beauty of this? The beauty of this is that plus 3 squared minus 3 squared is what? 0. That is what I wrote here is still the same as the question we have here. Yeah, it's still the same as the question. Are you get what I'm saying? All our aim is now that, this is squared and this is squared. So I can write it as x positive 3 all squared. Then I have 3 squared. This minus 3 squared. We've implemented this. We've not implemented this. That will now be minus 9 plus 5 equals 0. So we can say it is now what? X positive 3 all squared minus 4 equals 0. That's the answer. So the vertex will be, now comparing this equation, comparing this one we get here, right? Comparing this one, let me make use of something unique. Yeah, thank you. Comparing this one here, right? Comparing this one here to this one here, you notice that what? Our a, the coefficient is 1. Our s is still s. So since our h is negative here and this is positive, so we say minus h equals 3. So h is going to be what? Minus 3, comma. And our k is positive here, but this is negative. So our k is going to be what? Minus 4. So that's the vertex of that equation. And I will tell you something beautiful about what I just wrote now, but still wait a bit. Let's finish the question. Now, number two. Let's go back. Number two. What do we have there? We've got 5s squared minus 20x plus 25 equals 0. We've got 5x squared minus 20s plus 25 equals 0. Now the next thing, just like we said earlier, make this way. 5x squared minus 20. Let me erase this. Minus 20. This is 5x squared, remember here. Minus 20s, then plus 25 equals 0. The next thing, you must make the leading coefficient. This one, you must make it of 1. it must have you must normalize it. What am I normalizing? You factor the 5. Then you say into bracket 5x squared divided by 5 is what? X squared. 20 divided by 5 is what? Minus 4x. Then you wrap this, then plus 25 still equals 0. Are you getting what I'm saying? Now that works for this part. It will not get to this point at all. Leave this one here, leave this one. It doesn't have anything to do with this. This is the one you want to run perfect stuff around. And by the equation, by what we were given before, it must be of coefficient 1. So if the coefficient of the question they give you something of this image, if it is greater than 1, then you divide both sides, divide this and this by that thing by factorization method. Do you understand? So I factored out 5 here. It doesn't matter if it is common to this and this. All you have to do is whatever the coefficient of this that is not 1, you factor it out. I get what I'm saying at all. I'll give you another example and then there'll be classwork, an activity following it, so that you can just drop your solution on the comment section and we'll see how we'll move on, help each other from there. So the next thing you want to do is to find the half of this, square it, add it and subtract it to both sides, to this one there. Now, so this is going to be 5 into bracket x squared, still write your minus 4x, then minus 4, half of minus 4 is minus 2, that will be plus minus 2 squared, then minus 2 squared, close it, plus 25 equals 0. Don't mind me, I write plus 25 equals 0 there. Now this one here, now this one and this one, union of squares, this one and this one, this one and this one, this one and this one, union of squares. So that will be 5 into bracket x minus 2 all squared. There's a minus here, so that will be x and the minus 2 all squared. Then there's still a what? Minus 2. So there will be minus inside the bracket, because whatever you add to this, notice it's don't mind me please, that was an error. Let me rewrite the solution correctly. This is 3 minus 4. Now there's something around this place, right? We said whatever you are adding to this, you subtract it from this. So the minus has nothing to do with this one being negative. There will still be minus, and the minus of this one will be inside this place. So that's the point. Now we continue. So that will be minus, still a big bracket, minus 2 square, minus times minus plus, and 2 square is 4. Close the bracket, plus 25 equals 0. And then we have what? 5 into brackets. Then that's going to be what? You can now open the bracket 5 times the whole of this bracket. That will be 5 times that is what? S minus 2 squared. 5 times minus 4 minus 20 plus 25 equals 0. And then someone say, what's the answer now? Of course, it's going to be 5 into brackets x minus 2 squared plus 5 equals 0. Minus 20 plus 25 is what? Plus 5. So our vertex. So the vertex here is actually, now comparing this our result here, right? Comparing this result here to this standard format here, our h, if it is negative now, so we have x minus h and x minus 2. So h is going to be 2. And this one will be 5. So that is the vertex of this particular quadratic equation. So that's the beautiful thing. You can convert a quadratic equation from the standard form to vertex form. Let's quickly solve the last question there. The third question there. Number 3. Now number 3 now, what do we have? We have 3x squared minus 7x plus 9 equals 0. 3x squared minus 7x plus 9 equals 0. 3x squared minus 7x plus 9 equals 0. Now the next thing we want to do is to actually, of course, run a little bit of separation, in the sense that you write it as 3x squared minus 7x, then positive 9 equals 0. Now the next thing we want to do, factor out the 3. That's what I said. Now you notice this and this, there's not, in fact, we call them those two kind of number, they are relatively prime. We have nothing to do with that, because the rule is that we factor out the coefficient of x squared first. So that will be 3 into brackets x squared minus 7 over 3x. then plus 9 equals 0. The next thing we do is to write what? The half of minus 7 over 3. That will be minus 7 over 6. Add it to it and subtract it from it. So that will be 3 into brackets x squared minus 7 over 3x plus into brackets minus 7 over 6 squared, then minus into brackets minus 7 over 6 squared, then close the brackets, then plus 9 equals 0. Now this is squared and this is squared. Union of squares, union of squares, union of squares. So that will be 3 into brackets x. Let me have a big bracket here first. Okay, let me make this another bracket. Very good. So x minus 7 over 6 all squared. Then minus, are we good? Minus 7 raised to power 2. That's positive 49 over 36. Then plus 9 equals 0. Now the next thing we want to do, of course, still beautiful. 3. Then we still have 3 into brackets. We can now open the bracket. 3 times this, that will be 3 times the whole of this here, and that will be what? 3 times x minus 7 over 6 squared, and 3 times this, that will be minus 49 over 36 times 3. 3 in 36, 3 in this, that will be 12. So we are left it was minus 49 over 12 plus 9 equals 0. Let me re-explain that step very well. I don't want any issue around here. What we did here, right? What we did here is just to say, now 3 times this, opening bracket, 3 times this is this. Now 3 times this, that will be what? 49, let me write it here, minus 49 over 12 times, over 36, sorry, this was 36 from the start, over 36 times 3. So you say 3 here 1, 3 and this is 12. So that's how I got something here. That's how I got this. That's 3 times the whole of this. That's how we got this here. Now let me okay, I'm trying to erase it. So let's continue. Now, so with this, we want to run little fraction around here. Let's run this here. That will be minus 49 over 12 plus 9 over 1. Now, the LCM of that is what? 12. 12 in 12, 1 times minus 49 is definitely minus 49. Then 1 in 12, 12. 12 times 9, that's 108. So we have negative 49 plus 108. That's get to be negative 59. So positive 59. So that's get to be 59 over 12. Are we cool? Is anybody there? Do you understand? Thank you. So that's 59 over 12. 59 over 12. So let's erase this. 59 over 12. That's the final thing we come out with. 59 over 12. So we continue. So this is definitely what? 3 into brackets x minus 7 over 6 squared positive 59 over 12 equals 0. So what's our vertex? Our vertex here, let me make it beautiful, not too boring. Our vertex there, I'm looking for a unique color. Okay, this. Our vertex there, right? Our vertex is what? Now comparing this equation, comparing this to this. That's what we've been saying so far, right? Comparing it to this beautiful looking expression here, or equation. That's a into brackets x minus h all squared plus k. Then we'll notice that what? Our h is going to be 7 over 6. And our k is 59 over 12. And that's the vertex of this given quadratic equation. So that's how you convert quadratic equation from standard form to vertex form. And if you want to change the order, just open the bracket, expand it, then you get it back to the initial spot. Are we together here now? So that's just a beautiful key around that. And with that, you don't have any issue at all. There is something important you need to know. Something very important. And what is that then? This given quadratic equation, I will show you how you can plot the curve given a vertex form of a quadratic equation. Now you know how to convert. a quadratic equation from standard form to vertex form. I will now show you how to plot a whole curve without giving any value. They don't give you any value. You know, if you have to plot the curve of quadratic equation, any quadratic of the will tell you, okay, given a standard form from x range from minus skinny curve to plus skinny curve, from minus 2 to 3, from minus 3 to 6, they'll give you the range of x to which you can now plot the curve. But I will show you how you can plot the curve without giving anything. You don't have any information. All you have is just the question. And then they want you to plot the curve. Somebody is saying, is that possible? Of course, you see it in the next video. That's why you need to always ensure you check our next video for you to be updated, and at least for you to enjoy the whole series, so that one day you stand and you teach quadratic equation without any stress at all, and you are telling somebody just the right thing.